Okay, it's 3 o'clock. Welcome everyone to this 14th webinar of EAAP. We have had different subjects in the past, and I think one of the first webinars was also one focusing on insects. And now we have a very interesting program for you today with the title Taking Flight, How the Insect Farming Industry is Growing. And very happy that we have today a number of speakers from the industry, but also from academics to give their view on the situation currently in practice, and very curious to hear what they will bring us in the afternoon. First, in the introduction, I would like to focus for those of you who are not that familiar with EAAP and especially the Study Commission Insects. I give you a brief overview of what happened in the last meeting in Porto in EAAP. This was in September. We had elections in the commission. I was the president of the Study Commission, and now Laura took over the presidency of the Study Commission. And I present also here the other commission members to you, Anton Gligorescu, Christophe Sendrock, David de Ruiter, Thomas Lefebvre, Daniel Murta, Maria Martinez Castillero, Matteo Ottoboni, Cassandra Maya, and Ilaria Biasato. They all together are a very active team and organizing the annual event from EAAP, focusing on insects, but also in an event we have today, such as this webinar series. The Insect Study Commission is the European specific network on insects as feed, food, and non-food, and biomass as substrate for insect rearing. So I mentioned some topics here: nutritional requirements of insects. That's what we would like to work on. Insect production, processing methods of insect products, feeding value of insects and insect-derived products in animal feed, functional property of insect products in animal feeds, market applications, regulatory issues, consumer acceptance, environmental and socio-economic sustainability. Also, the last presentation of today is more focusing on sustainability, presented by Sergei Smetana. He is not yet here, but will attend this meeting later on. The activities of the EAAP Study Commission Insects, preparation of the draft scientific program for the annual EAAP meeting, selecting the themes to be included in the program. Within a few slides, you can see the program for next year. Preparing the call for abstracts and review of the received abstracts and establishing chairs for the different sessions. Dissemination of activities of the Insect Study Commission, planning of webinars, workshops, and also we manage the insect website. An example, the main page of the website, you can see, you can find here a lot of information on events, for example, on the right, news items, and also up to 2021, we included a lot of insect papers on this website for everyone who is interested to see how different experiments were done. Looking for main results they can apply in practice. So we made a selection, but since the number of publications is increasing very fast, also this task is a big task for the Commission to keep it updated. So we are a little bit behind. So up to 2021, all publications are here. The annual meeting next year in 2023 will be in Lyon, in France, from August 26th to September 1st. And in this event, we have for insects, we have 4 theme sessions, 1 project session, 1 working group session, and 2 challenge sessions. Maybe already good to write it in your agenda. The abstract submission is February 23, and the different themes are mentioned here. Insects in a sustainable world. This one will be organized together with the WAAP association. Learning from other production sectors, how other sectors succeeded. Insect nutrition, substrates, and insect health and welfare. Technologies in insect production and controlling quality. Insect product applications, legislation, safety and impact on society, insect genetics and reproduction, and there's a project session of the project farming, which will end next year. So a lot of presentations will be in this session. The program for today. So we are now in the introduction, and then we have 2 speakers before the coffee break and 2 speakers after the coffee break. They all have half an hour time available for the presentations, and they aim to have presentation of 20 minutes. So we have time after the presentation for questions. And then we try to wrap up a 5:15 to 5:30. Some organizational issues and last information after each presentation. 10 minutes Q&A, and the questions, you can ask your questions in the chat box, and Laura and I will look into the chat box and ask the questions to the presenters. The webinar will be recorded and further available on the EAAP website members restricted area, but after 3 months it will be public, available on the official EAAP YouTube channel. And I would also like to attract your attention to the next EAAP webinar, which will take place on November 8th from 3 to 5, with the title Control of Greenhouse Gas Emissions in Ruminants Farming. And with that, I think, Laura, we can start with the introduction of the first speaker.
Yes, good morning to, good afternoon to everybody. I'm really pleased to be here. So let me introduce the first speaker. The first speaker is Lars Erik Lau Ackman. Lars is head of business development at the Better Insect Solution. Better Insect Solution is an international leading technology provider of total solution for insect farming. He has a background in biology with quite extensive experience in research and development and business development. During 2014-2020, he has leading insect farming for feed and food at the Danish Technological Institute. And in parallel to that, he was very active in task force group at the EAAP. EAAP is the International Platform on Insect as Food and Feed. And Lars worked very actively during 2016-2020, as well as a member of the executive committee from 2018-2020. So today, Lars will give us a presentation entitled Diversifying into the Insect Sector, an Equipment Supplier Perspective. So Lars, the floor is yours, and thank you for your presence here.
Thank you, Laura. Thank you, Toyn, for the invitation to join this webinar. I hope you can see my screen, everyone. Yes, I hear no complaints.
Yeah,
so
yeah.
Yes.
Excellent. Yeah, I decided to hack the title a little bit, actually, because from Better Insect Solutions, which I will explain in a bit more detail what is behind that group, we see ourselves actually much more as a systems supplier than only equipment, but that is a formality, you could say. Better Insect Solutions, it's a group effort that comes out of a family-owned German-based company, also better known as the Big Dutchman Group. And for the last couple of years, we have worked intensely to bring together our existing technologies and developing also new solutions to bring a turnkey proposition for insect farming to the market. And I'll give a few examples of that later. I would like to start a little bit with regarding perspective, because you could say, why does a big organization like the Big Dutchman Group get interested in insect farming in the first place? It's not something that happens overnight. And there has been a lot of work done by the insect sector, not only to catch the interest of the Big Dutchman Group and other how can I say, external industrial stakeholders to join, but there has been a lot of momentum built over the last 10 years. So I would like to start with a little bit of testimony and humble appreciation to many of those from academia and the NGOs and governmental organizations that saw the light and created a vision for insects as food and feed probably a decade ago, depending on when you start counting. But definitely there was a very defining moment in January 2012 when this group of people, of which you probably can remember a few, some of you that have been around for a couple of years, Arnold van Hoes should be mentioned here for sure, who together with Paul van Tom with the sunglasses to the left, were hosting this and were part of the rest of the group here to ignite that insects as an alternative could be maybe an answer for the future. But of course, it took more than a few good ideas and some visions to make this become structured and to make it into some functional unit that an industry could start growing from. And I believe personally that here the different trade associations that are now quite active in the major regions, NASIA, IPIF, and AFIA, have played a big role in getting the insect sector organized over the last decade, where IPIF initiated this work back in, unofficially though, back in 2012, but nevertheless ensured that a platform was created from where dialogue internally amongst the stakeholders of the young insect sector at that time could happen, but also created a channel through which a dialogue with authorities and stakeholders from neighboring sectors like feed and food could also be undertaken. And this was quite important that the sector got organized. And then if we fast forward to a few years ago, then I would say that we have seen a lot of external non-endemic insect companies, if we can call them that have joined this sector and which has started to create a momentum beyond what happened in Rome back in 2012, so that now this is really taking shape. And I believe we are moving into from and there's no ill meaning to saying that it has been an R&D dominated era that we have been in the last 10 years. Now we're going into a commercially dominating era, which will still need a lot of innovations and R&D, but where this sector starts to get as a self-sustainable status, being able to run on its own through commercial activities. There are still a lot of challenges in this sector, of course. I mean, only 10 years old, still not quite grown yet, and already a lot has been accomplished. I have tried to boil it down to three major challenges in this slide. If we start from the bottom, the the challenge of consumer acceptance is one not to be dismissed, but it is primarily a challenge which is of big concern when we are discussing insects as food. So I'm parking that one here today. Also, if we move upwards, regulatory legislative barriers in feed and food, and also how to apply insect frass as a byproduct has certainly been a challenge, particularly in Europe, North America, but also in other jurisdictions. A lot has happened there during the last 10 years due to the work of the trade associations in particular. And today we are in a situation where it's possible to operate commercially, although there are still challenges within this topic to be dealt with, and there will be for many years, because insects have been put in the farmed animal box, so to speak, which is great, but that box was built for pigs and poultry and what have you, and so there's a lot of elements that are not fully suitable for insect farming. But the challenge, the top challenge that I'd like to highlight today in particular is upscaling to meet market needs. And this has to do with making sure that the production volumes of insect protein meal, oil, frass, what have you, reaches volumes at a sectorial level that can actually meet the demands and needs of the feed sector, the food sector, pet food, what have you. And there's still some way to go there, because we are talking millions of tons of meal that could be used globally, but we are still not past the first million. But I believe firmly that this will happen within this decade, and a lot of good projects are being started out there that are trying to deal with this challenge, making sure that there will be hubs of tens of thousands of tons of larvae or meal being produced at various sites in all regions. If we look at where we are today, and here I borrowed a little bit from IPIF. If we look on the left on facts and figures, today the sector, according to the survey of IPIF, already is employing about 1,000 full-time equivalents or full-time employees per year. And this is believed to be more than 25 doubled within this decade. So that's a massive increase in jobs. And also there will be a massive increase in the investments expected to go in the direction of insect farming. Already €1 million has been invested so far, and this will triple already within a few years. And this is definitely needed, because insect farming often is it's often large-scale operations which costs many million euros to get up and running in the capex. So those billions will quickly be used, I'm sure. If we look at which markets that these producers are addressing, then on the right-hand side we can see here a relative distribution of the protein meal to the main markets, where pet food and aquaculture are battling somewhat regarding who will be the biggest now and by the end of the decade, both comprising quite a substantial part of the market for insect meal. But also broilers and layer hens, so poultry in general, will altogether be a quarter of the market for insect producers in a foreseeable future. From the perspective of an equipment or system supplier, it is very motivating to see that there is an increased involvement of different types of technology providers into the various segments of the entire value chain, focusing on insects for feed and food. The picture you see here on the left, it's from the IFW meeting in Canada in June earlier this year. And this was an industry panel debate where, apart from Better Insect Solutions represented by myself, there were also other large industrial stakeholders in the panel, VDL Insects, Bühler, to mention some like-minded stakeholders. And this is a great achievement, or maybe not achievement, but a great development for the sector, that there is a diversity of technology providers that can help supporting this challenge of scaling up production. Because if there was only one out there, it would create a lot of risk. What if the solution of that one stakeholder was not sufficient? This would make the investors uneasy, and hence it would slow down or inhibit the growth of this new sector. So you could say, in other words, where would Coke be without Pepsi? It's the same for technology providers in the insect segment. It's important to have competitors and collaborators that can ensure that you stay innovative and also de-risk that you are not the only solution out there in the market. That's one perspective. It's also very important to continue focusing on specializing the production process. There will still be many full liners in the years to come, producers of insects that have both the adults and the rearing part. But we will also see, and this will also to a large degree de-risk and accelerate the development of the sector, that there will be companies. It's already happening. Thomas from Beta Box is an example of that, and we'll give a presentation later, that there are breeding companies that support this sector now, just like there are also rearing companies that focus only on converting byproducts, waste streams to high valuable protein, meal, and oil. I think what kind of covers it all is that in order to strengthen this further, it's still very important, and this is opening up. I have worked myself in this sector for over 8 years now, and initially it was a very closed, it was a very secretive sector for many good reasons. The investors wanted to make sure that the golden egg that they were focusing on here would not be shared too publicly with others. But I believe that it has opened up, and I think this is something we should encourage and also support, that we should try and have more transparent partnering amongst various stakeholders throughout the value chain, so that we can accelerate and strengthen the development at sectorial level. And end of the day, it is in the interest of the individual producer or technology provider or other stakeholders that we create a strong platform at sectorial level, because this is still a very young sector. And in order to be able to scale up to those massive volumes that are necessary, we will need to be working closely together across borders and in transparent partnerships. I would like to give you one case example of that from the work that Better Insect Solutions has been doing with EAAP Biofactory in Denmark. There's a short 1-minute video here that I'd like to run, giving an overview of the pilot side of EAAP, and then I'll afterwards say a little bit about EAAP as a reference project for us, as well as use the final minutes to give you an overview of our technology solution. So bear with me and listen for a minute to this video.
In a new business area like insect farming, it is extremely important to be working closely together amongst different partners, such as the customers and the technology providers. Here at the EAAP site, we have from Better Insect Solutions, which cover Big Dutchman, InnoPlus, and SCOF, been working very closely with EAAP on finding the right solutions for climate, for heat recovery, and for liquid feeding. At EAAP, We have been working with climate systems to ensure good growing conditions for the larvae and the flies, heat recovery systems for making the operation energy efficient, and liquid feeding systems to ensure robust delivery of high volumes of feed. For Better Insect Solutions, it has been very valuable to have this collaboration with EAAP, ensuring that we can provide robust, cost-efficient solutions for the future of insect farming.
So here's a little bit more on the project by EAAP, where we from Better Insect Solutions provide a lot of the key technologies. The video you just saw was from this pilot area, 2 old broiler houses actually that were refurbished back in 2019. And here EAAP have been running a 500-ton black soldier fly larvae production per year until now. And as we speak, this project is being scaled up with phase 1 being the pupa section, 1,000 square meters of rearing facility for pupa, which is going into commission end of this month. Next phase, where the building is erected already, is the fly section, and then by the end of the year, the building for the nursery and grow out sections, as well as processing and feed kitchen, will be erected to be finalized by next year. So in a year's time from now, this will be a 36,000 ton production of wet larvae per year. And here we are delivering many of our key technologies to this project. Zooming a little bit in on this, and going back to where I started with, that Better Insect Solutions have emerged from the Big Dutchman group, bringing together different sister companies from the group, from Big Dutchman International, from InnoPlus, from SCOV. Here we have pulled together a lot of existing technology that we have actually used in pig and poultry farming for decades. A lot of the technology that we use in a farm that like EAAP that you have just seen, it's technology that that exists already. Although different systems do have though required a certain amendment, but the building blocks, the Lego bricks, are the same. So the climate system, for instance, has required quite a refurbishment, but it's the same ventilators, heating system, etc. that we use. The feeding system has required a little less amendment, but still some amendment to provide precise dosing of volumes at high speed, which is required for insect farming to a much higher extent than for pig farming. And then our heat recovery systems have been a technology which we have been able to plug and play quite easily, because exhaust air coming from a poultry or pig farm is not much different from exhaust air coming from insect farming, except that there's a lot of heat coming out of an insect farm and a massive potential to recover the heat from the insect farming operation, actually to an extent that you can run your entire farm on the exhaust heat that you recover, as well as having a lot of excess heat for other types of operation. There are some elements where we have had to do complete new product development, like specific crates to fit with our climate systems and different types of sections, whether it's a nursery section or grow out section. Breeding system for flies has been a complete new endeavor for us, because this is something we were not used to previously from poultry and pigs. The same goes also if we talk about technology that we've needed to pull in from the outside, working with a few trusted key partners. For instance, logistics. It's not a technology, automation and logistics. It's not a technology that per se is normal to other conventional farming like poultry and pigs that are not put into boxes and palletized. So here we are working with a few trusted external partners. And also if processing is needed, again, not a classic animal farming technology, here we also bring in external partners. And with those external partners, we are able to provide turnkey solution, and not least because we can wrap it in a nice building too. Final remark is that for taking the step from a small scale up to a large scale operation, it is very important that you have validated your production, validated your KPIs previously to make sure that your business model fits or your business case fits, so that you don't get any unwanted surprises when you present the final prospect to your investors, telling them that, okay, we are asking now for the big investment to go from our small scale / pilot operation into large scale production. And here we have developed some container-based solutions where we can deploy technology which is directly comparable in proportions and dimensions as our large-scale offerings regarding both, for instance, climate chambers for the larvae, we call that the grow box, or a feed kitchen for making sure that the feed added to the boxes, added to the crates in the grow box is homogeneous and easy for the larvae to assimilate. That was the perspective of Better Insect Solutions this afternoon. I hope it has raised a question or two. Thank you.
Thank you, Lars, for a very interesting presentation. And yeah, it was nice that you start from 10 years ago and show the development and also the associations, etc. And so it's you can see that it's very important to be associated as industry and also as research.
I should have put EAAP there too, Toyn. I'm sorry, but I focused on those working with the legislators directly, but they're more than the three, yeah.
And to see and really the challenges you demonstrated, the upscaling, regulatory, legal barriers, consumer acceptance, and also give an insight in norm. So impressive, and I can imagine that there are some questions. And do you have the chat open, Laura?
Yeah, I have the chat open. There is no question in the chat. I have nothing to.
You've got raised hands though, Laura. I can see some raised hands somewhere. At least it's showing in attendees. There's 2 raised hands.
I don't see.
Tatiana Schwaber-Markovic and Charlie.
Yeah, but I will need them to write their question in the chat.
Okay.
If it's possible, please write the question in the chat so we can answer. We can.
Taking a little bit advantage of the situation in between, then I can encourage you to follow our LinkedIn page, Better Insect Solutions, where we put a lot of news on what we do, including what happens here at the Norm project.
I see that there is one with well, Charlie. Okay, Charlie, could you please put your question in the chat? No. So
yeah, I have a question for you, Lars. In the meantime, looking ahead, and that's very difficult. I know 8 to 10 years, but the development you see in the market now, do you see currently already a development of decentralization in the market, or?
Oh yes, we sure do. There are both many that would like to, how can I say, not having to deal with reproduction with flies or beetles if it's mealworms, because it is somewhat more complex than dealing with the actual rearing. So that's one driver, you could say, and also as I'm sure Thomas will will give a few words to. There are also a number. I think personally, I know of a good close to 10 different companies globally, and there are probably more than that, that are focusing on providing genetics or stock, livestock, insect livestock, neonates to these rearing facilities. And I think for several reasons, it will make sense for many to start this way. It can be both in the pilot phase, not having to focus. This goes back a little bit to my specialization point. I think this is also very important if you are starting up a new operation. Don't try and solve the entire puzzle from the beginning. Maybe start with focusing on unless you are going to be a breeding company, of course you need to deal with the breeding. But if you want to be converting organic waste streams, what have you, then you should focus on showing that you can get a business case balancing with that bioconversion part. And then maybe if you are big enough later, it makes sense for you also to take on having your own breeding facility, but in a transition period, and at least also initially, it would be good to focus on the rearing part and then team up with some of the breeding companies to support this.
Yeah, Federico, I received a message on my telephone saying that the chat is not, it is not possible to write things on the chat. So maybe this is the reason why Charlie was not able to.
Okay, Laura, we are checking it.
Thank you. Okay, now it's available. I don't know if Charlie, Charlie, if you want to put your question in the chat now, we can ask Lars. I had a question around the heat recovery of the facility. Would you be able to expand on this, please, Lars?
Sure. So from our setup, the exhaust air from the different larval-based units, it goes into a common exhaust channel, or at least a number of larger exhaust channels that go into a scrubber. It's a transmission of air to water, where both you can scrub, you can clean for ammonia, reduced by adding acid, so you can reduce odor levels by other chemistry. But in this scrubbing setup, you can also recover the heat that is in the exhaust air. This can be done in two steps. The simple step is by mere convection of the heat that is being transferred from the air as it passes through this water phase, which is basically a shower. And that can, through a heat exchanger, be bypassed back via some pipes to the incoming air that goes into the houses. So here you have like a radiator where the air is taken in, so that, let's say, like if in Denmark it's 5 degrees outside, from this step one of the scrubber with heat recovery, you can get 15-20 degrees on the inside when it passes through this heat exchanger. The second phase, which is necessary, which can be added, is connected with a heat pump system, where you kind of harvest through extra technology the heat that is more difficult to get out of the water. You can get out in this second phase and integrate it into the heat pump system, which then can be the main heat source for the internal heating system inside your insect houses. So inside the climate chambers, you then attach the heat pump system with the water-based heating pipes, so that actually the exhaust air, it both preheats the incoming air and also heats inside the actual climate chambers. The heat that goes out of it, and this is particularly the grow out part, so the final phase where the larvae are growing, that generates an immense amount of heat. It's actually to a level that you can generate up to twice the amount of heat that you need to operate one farm. So in this regard, you have quite a lot of excess heat that you can use for a lot of other operations. This could be preheating your feed so that the larvae are not dipped into a 15-degree cold feed when they start growing, because then they won't start growing from the beginning. This can also be your washing machine facility, for instance. There are a lot of different opportunities. This could also be in the future, maybe supplying a neighboring greenhouse of substantial size with heat all year round. So there are many possibilities. So maybe this will be the secret weapon in the energy crisis. Who knows?
Well, I was going to comment on that actually, Lars. I think it'll be a bit like we'll have larvae, nuclear bunker, and the greenhouse on top in a very dystopian future.
It can.
We have some other questions. Do we have time?
We are 1-2 questions with a brief answer.
Very quick question. Can you elaborate on how you worked out ventilation requirements based on your expertise on poultry and pig house?
Yeah, I'll be brief. And of course, everybody is most welcome to reach out afterwards, connect on LinkedIn or whatever. We take first the condition, okay, where is the farm going to be placed? So what impact do we get from the outside climate? The local climate in Spain is very different from in Denmark, from in Southeast Asia, etc., etc. So that is the starting point. Here we're using meteorological data to get a climate profile over an extended period of time, which is the initial starting point for dimensioning the climate system. Then we look at stocking density of, in this case, insects, expected heat production per square meter. So this really means per level of square meter crate, because this is something which has been quite a development in our climate system over the last few years, that we were used to poultry houses, pig houses, but with insect farming, it's like 15, 20 poultry houses in the same room. So every layer of crate basically has the same heat production as the floor of a poultry house. So we estimate what is the watts per square meter from this production, and then according to those requirements internally, how much will the animals generate of heat, and what is the profile, how fast will it go, in context of where in the world is this farm going to be placed. Then we can, based on the climate profile you want to run with the various set points you want to have for temperature, for humidity, then we can make a dimensioning of your system that will fit those requirements. And the higher your requirements, the more ventilators, heating system, etc.
Thank you, Lars. I think we have to proceed. Thanks a lot for your presentation.
Thank you very much. Have a good rest of the meeting.
We will send you the questions that are in the chat, so you can directly interact with the person in the chat. Okay. Thank you very much, Lars.
Thank you. Bye-bye. So
let's go for the next speaker. The next speaker is Thomas Ferrugia. Thomas is the CEO at Databugs, which he founded after spotting the opportunity for improved genetics in the very rapidly developing insect farming industry. This led Thomas to establish an industry-first nucleus population and selective breeding program for the blacks of the fly. Thomas believed that the insect farming sector will segment, and with Databugs and genetic form part of this supply chain, and supplying quality, genetically improved livestock for rearing of the blacks of the fly by insect farmers. So today, Thomas will give us a presentation entitled "All Producer, Great and Small, our industry need them all." So please, Thomas, the floor is yours.
Brilliant. Thank you, Laura. Let's see if I can get the slides up and running. It's always classic. 1 second. If I can just get a confirmation, if you can just see the presentation rather than the notes.
Yes, it's on.
Can see.
Okay, brilliant. Okay. So, yeah, Thomas Ferrugia, CEO of BetaBugs, and I came up with the titles for these talks. And this is going to be an interesting one because I've been thinking about what did I want to drive through when I came up with the title for this. And really it's about how I think it's not just, it's a case for everyone can produce insects, and there can be a range of scales, and it's down to what scale you want to operate at. And actually, and so what I've done here in these slides is put together a bit of like what's available, what's the factors to consider, and just some thought process around that. So first, though, I always really find it interesting to think about Blade Runner 2049. And this is like the opening scene in the film, right? It's this protein farm. And this was back in 2017 when the film came out, just when we were starting BetaBugs. But it's that idea, right? It's you're growing stuff, and it's not a very big farm. You've got spirulina on the side, and then you've got the bugs in the pond. And it just captures what insect farming could be like. I'd hope it's not like in Blade Runner 2049 where everyone's living after a nuclear holocaust, but protein is there and it's bugs. And the message really is, as I was saying, there are many ways to get involved in our sector and to be an insect producer. And this is what I'll be running through in general. So I'll do a bit of an introduction as well about BetaBugs to give people an understanding of what we do, how we drive that industry as well and help it. And then the main part of it is these facets within the industry for aspiring producers to consider. And then we'll just close off and have some Q&A. I'm sorry, I had COVID last week, so still recovering a bit. But in terms of what we do at BetaBugs, we develop and distribute breeds of black soldier fly to insect farmers, and that's effectively an insect genetics company. When you think about it in other supply chains, you've got pigs, you've got genus, chickens, you've got AVGen or Cobb for broiler, Hendrix Genetics for layers. So there's always genetics companies which enable the industry to progress by improving productivity in the animal. And effectively, you then combine the animal with the hardware. So that's what we're doing. We run a breeding program, and I'll touch a bit on this in a second. We're based up in Scotland, in Edinburgh, and we're co-located next to the Rosalind Institute, which are pretty good at animal genetics as well. So there's a bit of collaboration ongoing there. Genetics is important because it's one of two pieces which a producer will need to make protein. So you've effectively got kind of Lars before from Better Insect Solutions explaining that there are these hardware systems which they produce and other companies produce as well and supply to the sector. And similarly, you're then going to have this hardware, but you need to plug in the livestock. And livestock come from a range of companies. You've got egg producers, you've got genetics producers, you've got genetics and egg producers, which is where we are. And you effectively install your animals into the production system and use those to make the outputs, your protein, your live insects, oils, frass, whatever you're wanting out of that production system. Now, the beauty of the genetics is you can keep improving on it. So you just keep improving on the genetics. And what that means is you've got this fixed asset, which is your production system, and you can squeeze more productivity out of it by improving the animal. And that's what's been done with pigs, fish, chickens, plants. When you look at a hectare of land, the output of crop has increased because the plants are more productive. It's not because there's more land. It's the same with chickens. Chickens today eat less food. Well, they grow faster, they grow bigger, and they use less feed than before. And that's effectively enabled chicken to be so cheap in terms of the production cost. And this is where we see ourselves with genetics. It's all about making a larva which grows bigger, faster, has better survivability, and a fly which will also lay more eggs. We effectively wrap that into a product called Hyperfly, high performance fly, which we then supply to industry. Supplying Hyperfly, there's a bit of a challenge because when you're on the breeding program, you're at the very top of what we call a multiplication pyramid, so the very top of the genetics, and that's a small population. What you then need to do is scale it up. So that's where egg production comes in, and that's what we do at the multiplier, which is effectively a large egg production site, and we then supply our customers from that. Customers grow hyperfly, they get better productivity, and that translates into improved bottom line for the producers as well. Right, if you wanted to, I'll just flag one other thing before we dig straight in. And this is effectively an industry publication we put together called BetaBuzz. It's a really good way of getting to know about our industry. We've put together material from a range of equipment suppliers and different companies offering services. And it's just a really, it gets you everything in terms of, if you want to start out, have a read, it'll tell you what you need to know. And it'll signpost you to people who can help as well. So Big Dutchman and Better Insect Solutions have advertised in that as well. We've got companies like shipping container companies. So stuff I'll be referencing is in BetaBuzz. And if you're interested in actually contributing or anything like that, feel free to get in touch as well. All available online, and you can get print copies as well if you fancy it. So I'll be talking about black soldier fly larvae because that's what we operate in. So this is kind of BSF context rather than mealworm or anything else, but the same concepts do apply in terms of production. And you've got these two stages, right? You've got the larva, and then you've got the fly. And I'll touch on that a bit as well. And the larva is what makes the protein. The fly is what makes the eggs and makes the larva. When we see people wanting to form this, there's a number of reasons. Some people just want to turn waste into value. So this is effectively reasons to be a producer. Turn waste into value. You can produce a protein with a low carbon footprint, a protein that can be used for on-farm feeding, and then you've also got the frass coming off. So there's also this frass play around fertilizer. And what's really interesting, I think, is given the sensitivities in the agri-food supply chain now, along with carbon as well, there's a real drive for the uptake of insect protein in these supply chains. In the UK, we're now seeing, for example, the development of carbon neutral eggs within retail supply chain, and that's being facilitated through the use of insect protein, for example, along with having a fair amount of renewable energy on farm and being able to sequester carbon dioxide on land. So it's not just from the insects, and I think we've got a great talk a bit later on terms of sustainability of insect protein, but it does form part of that solution. In terms of life cycle, for anyone who's not familiar, we've got flies which lay eggs. You've got this kind of intermediate step of 5-day-old larvae when they hatch out of the eggs, and then they become larvae, which is what gets turned into protein, pre-pupa, pupa. And the pre-pupa and pupa is effectively the bits before they turn into flies, and then you do the whole cycle again. One point I want to make, and what Lars was talking about with segmentation, is where you can segment neatly is around the eggs and larvae. So effectively, you can have eggs and 5-day-old larvae producers, and then you've got your protein producers, which are just about mature larvae. And this allows you to centralize or decentralize the system as you see fit. So if you're doing a full life cycle, so Enorm, for example, which Lars was talking about, would be running a full life cycle. They'll do the whole thing and produce their eggs in-house. Other producers might decide to just chop off that bit and buy the eggs or the 5-day-old larvae in and just run a larvae rearing operation. And the reason you do that is you can dedicate more floor space to your larvae rather than having floor space for cages and all that. And it is effectively, when you think about it, two different animals. You've got this fly, which needs space to mate in, and it needs specific temperature and humidity conditions. There's a whole different operation, egg collection and all this. And then you've got the larvae, which basically just want to eat and grow, and then you need to harvest them. So you can really see that there's two distinct operations which kind of interplay on each other. So if you split it, which is what's been happening in, or what's been done in the, say, pig and poultry sectors, then you can actually just focus on being really good at, as a producer, at producing larvae. So this is to give a bit of context in terms of that supply chain segmentation. We're seeing things like, I had alluded to, I think, previously, is vertically integrated insect farms. So these were the big farms which came online earlier on. As Lars was saying, there's a lot of R&D initially. And these are the guys who are building these large-scale facilities, which are effectively a full life cycle operation. and it's all primarily done in-house. And now we're seeing specialized solutions companies, which are kind of all focusing on different parts. I've taken a few examples here. I mean, ourselves, we clearly come in as under genetics and supply of eggs. AgriGrub in the UK is a farming company really focused just around the protein production. We've got Cogastro in Lithuania, which does farm management software, which is really interesting when you think about it. There's now these solutions developing for our sector. And Genofeed in Israel does actually a really cool solution around increasing, basically turning the larva into a complete feed for fish. So there's all these solutions emerging, and these are specialized solutions companies. And then alongside that, we're seeing equipment providers and contractors, you know, who will enable you to build a facility. So these are the companies you reach out to in terms of if you want to get the CapEx in, if you want to get the site built. These guys can offer a turnkey solution or parts of the solution, and that means you can then, again, focus on producing, which is what you want to be doing as a producer. And this also ties into why we're seeing insect farming really crop up. There's more and more equipment available. Before, you would spend a lot of time working out what you need and what you want to do. We're now seeing it develop further. I think the three kind of production motifs in a way, or motifs, the three production motifs are trays, bioreactors, and I'd say racks. Trays are effectively a box, and you grow the things in, you pile them deep, you pile them high, good ventilation, and you will in some shape or form end up running a lot of trays down conveyor belts at some point if you scale up, but it does work, and it's been done in the large scale production systems as well. The other option is what we call a bioreactor system. These are always interesting because you realize you're talking to a bioreactor person because they talk in meters cubed. And this is an example where it's a rotating drum, and you can kind of stack them next to each other. In theory, you could stack them high as well, but it's effectively a tray, which is, rather than being flat, which is folded and just rotates. And lastly, there is the rack systems. I've not seen many of these apart from insect engineers, but this is effectively, when you look at this, the mushroom farming production operations, but applied to insect farming. And this allows for very fast loading, unloading, and processing. Again, this is all existing agricultural equipment just being reapplied to insects. There's also this different farming scales available when you think about it. So you can have containerized systems, which will do, you know, tons per month, single-digit tons per month, usually, depending on the substrate you're using, to full site, which is, as Lars was mentioning with the norm, we'll be doing 36,000 tons a year. So that's 100 tons of larvae a day. And you can go anywhere in between. You can start out, I mean, what we tend to see in this kind of progression of being a producer is you start out with a really small system, maybe even start out with a few trays, a starter pack, and then you move up to growing in a room setup. So maybe you get a grow tent, maybe you get a shipping container, and then you move from that to something bigger. And that's just so you can validate your process as you go along. There are changes in the process as you scale up, so that's something to keep in mind. And sometimes you will need to kind of scale through, you will need to work your way through it and ramp the process up gradually, rather than just make these big jumps. If you make big jumps, something will break along the way. You can try and fix it, can work, but as Lars was mentioning before, if you don't do it right, your business plan can actually break. In between this, oh God, losing my voice. In between this is probably like a pilot production system, basically. So you've got this container system, there's a pilot production system, which would be some sort of small industrial unit initially. And we see this a lot in terms of the scale up story. And then you go to a larger scale industrial unit. And you always need to be bearing in mind the inputs you'll need as you go along as well, like substrate. There's also different farming modes. I've talked a bit about this already. So you've got your integrated farming mode where you're doing everything in one space, in one building at least, or close by. So that's a full life cycle. You can go hub and spoke, where you maybe have one full life cycle facility, or you just have an egg production facility, and then you have lots of small facilities growing at different locations. And then you collect the larvae out. So that could work really well with, say, a lot of different shipping containers in different locations. and you've got one egg production facility supplying them all. You can also have decentralized, which is a bit where we come in. So you don't actually have the egg production facility, you just have egg production facility supply you with the eggs or the baby larvae to run in your shipping container, in your pilot facility, in your large scale facility. There's also an interesting variation on this, which is more a business model variation, but that's the contract farming, where you actually, rather than own all the facilities in a hub and spoke, you contract people to farm for you. I think this works really well apparently with smallholders in, say, Kenya and other places, countries in Africa, where people are looking for an income stream, and you supply them the material, and then you buy the material, the larvae off of them at the end, and use it in your own operation. And that seems to work really well. And that's not far off from what's done with chicken farming in terms of egg production. Large egg producers will usually have their own production facility and operation where they'll make a certain amount of eggs, but then they'll contract farmers to produce eggs for them, which they'll then buy and put into their product. So they'll pack those eggs and sell them to the retailers. There's also different products to sell. I think, and we'll see this more as the industry matures, we'll see nearly a first level of product and then a second level, nearly like a new tier emerging. I mean, the base of it is we've got the larvae, you can sell them live. You can sell, so I mean, we're in the UK right now, you can only use live larvae for feeding to poultry, which is a bit of a constraint, but so you can do live larvae, you can make a protein meal for going into pet food, pig food, chicken food, and fish food if you're in the EU. You've also got the fat, which is another component. Then there's frass, which is effectively the fertilizer which derives from the insect excreta. And then there's these other ones, which as I was mentioning, kind of like second level probably. But the idea here is you can actually also choose to be a frass producer to a degree, but that means you will probably be producing less protein and fat. So there's ways you can play it in terms of the interaction and the feedstocks you have available. Chitin is an interesting one. I think we are already seeing some companies really focusing on chitin and how can they refine it, because it can be actually a high value product. It doesn't come in, you don't have as much of it in an insect production operation, but it can still be significant in terms of quantities and possible revenue. And I put in the antimicrobial peptides and just proteins in general at the end, because it's something to think about. There are companies which are using black soldier fly as bioreactors effectively. And again, that's accessing this kind of high value market. And as I was mentioning, so these are the supply chains you can go into: feed, food. Fat can actually go into cosmetics, which is quite interesting as well. Possibly chemicals as well. There's the whole biofuel sector potentially as something to go into. Frass is a fertilizer primarily, chitin's pharma biomaterials, and antimicrobial peptides would be something for animal and human health as well. There's also different products will mean different substrates to a degree, because the level of product you get will be dictated by your substrates. So you can probably do a bit of a mix and match where you can combine. And I mean, the bulk of the substrates we see, we've got these agri-food waste streams, things coming out of agri-food which can be used to grow insects. That's great when it's up to scratch, because you can actually put that into the animal and human supply chain again, sort of the protein. Things like manures right now are a bit of a no-go in UK and Europe, but if you're using black soldier fly for a non-food purpose, manures become something to consider. You just need to find what you're going to do with that product. And I think in the future, again, as we see things become a bit more like regulations relax, we'll probably, it might be landfill waste, it might be sewage, it might be things we don't consider processing using black soldier fly or other insects right now, but you will be able to in the future. And again, that'll give you a different range of products you can access. So I think I'm going to wrap off here pretty much on time, but the idea is there's many ways to get involved in the sector and to become an insect producer. It is a good time to join our sector today because it's becoming increasingly easier to farm insects. You don't need to spend all this time in R&D locked up trying to work out the process. The process is becoming increasingly more available, and people talk. As I think it's really going to be like an actual farming industry, which you can get involved in. And to wrap, don't forget the three things you'll need. You'll need production systems, substrates to grow the bugs on, and genetics. And that's everything from me. So I'm happy to take any questions, thoughts, or discussion points. Thank you.
Thank you very much, Thomas.
Yeah.
Let's see if I can have. We have some message in the chat. No, those one were for Lars. So I have a question while okay, the question already arrived. Where do you get your genetic from?
Well, genetics are within the breeding program. I'm not going to dig too much into that, but effectively, I'll tie in Thomas's question actually with that. But how does the breeding program work? Is effectively it's a selective breeding program, and we effectively select for those traits in parallel, and we improve on them in sync. Just in the same way you do it with chickens, pigs, or fish.
So, and I think that the second question you already answered. How does your breeding program work?
Yeah.
Yeah. And are you able to share any details on your current capacity to supply eggs?
Yeah, so we're supplying, and if there's, depending on the size of order, happy to get in touch. We're doing in the range of hundreds of grams right now. So we're happy to, if there's interest in that kind of order, and beyond that, we're already in the scale-up process to increase capacity. So happy for Charlie to get in touch.
Thanks, please.
I don't see any other question coming up. How much has the conversion rate improved in recent years?
It's not clear to me what conversion rate, in terms of feed conversion rate for
I think the feed conversion ratio, yes.
So the feed conversion ratio, can't comment on that. I mean, it's actually really hard to do in black silverfly to a degree, because it's usually feed conversion ratio is a bit like an individual trait, but what you've got is a population, so it's a bit more challenging. It's work in progress. And Laura asks, which traits have you identified as the most important to select for? So for us, Laura, it's all about yield and hyperfly. So we select for larval growth rate, larval size, larval survivability, and eggs from a fly. The first three enable a larval producer to increase their yield. Mads asks, are we doing GMO? I think this is a really interesting hot potato question. I think it's always a possibility. I think I would flag that there's GMO and gene editing. Gene editing is effectively where you're working within the genome, and probably a bit easier on the regulatory front. GMO is when you put things in like jellyfish genes, GFP, to make them glow in the dark. That's a bit harder usually. I call it a hot potato because as an industry, we're really focused around the sustainability of the protein. We're focused around kind of the credentials of our industry. This is a hot potato because if we don't manage it well, it could easily get tarred as frankenflies and all sorts of things. And then our industry just does, and the same way that the whole breeding industry, when you had Monsanto come in with GM soya, and there was a lot of friction, and it really pushed everything back. So it's really one we need to handle as an industry, just make sure we're doing it right. That's my thoughts on that one.
Okay. Teun?
Yeah, and with that, Thomas, it's already 10 past 4. Yeah, so I propose we now have a coffee break with thanking you, Thomas, for a very interesting presentation.
Thank you. I enjoyed it as well.
Thank you. Thank you very much, Thomas.
And then at 4:20 we continue.
Okay, so let's have a coffee break and see you in 10 minutes.
It's 4:20 on my computer, so I propose to continue. Laura, can you introduce the next speaker?
Sure. So the next speaker is Daniel Murta. Hello, Daniel. Good afternoon. So Daniel is Daniel holds a master in veterinary medicine with a PhD in reproduction, Daniel Murta is the founder and chairman of Ingredient Odyssey since 2014. Ingredient Odyssey is a company that is dedicated to the industrial production of insect as a nutrient source for animal and plant nutrition. Daniel is also professor of veterinary medicine, has been professor of veterinary medicine at Lusofona University between 2014 and 2021. And since then is a professor of veterinary medicine at EGAS Molitz. Today, Daniel will tell us something about Together We Can Do So Much, partnership in the insect protein sector. Daniel, the floor is yours.
Hi, Laura. Many thanks for the invitation to participate in this conference. I will share my screen. Please, are you seeing full screen? Okay. So
we can see it.
Yeah, many thanks for the opportunity to join you today. And my challenge that you presented was to talk about Together We Can Do So Much in the partnerships in the protein sector. Well, many things have already been mentioned before, and I would like to focus more on the insect sector, but just a background, very, very small, why we are talking about the use of insects as a protein source. Well, insects can be a huge opportunity to tackle today's challenge, mainly due to feed ingredient prices getting higher and higher, and our dependency of protein sources from overseas. Europe is completely dependent from other continents, namely America and Asia, and insects can be a possible solution to not only increase the sustainability, but also the availability of different sources of proteins for animal feeding. So it makes insects to be several times mentioned as a possible feed source, mainly due to its protein composition, but also due to the sustainability that this protein can attain for the feed sector. Moreover, insects can be used as a tool to convert byproducts, mainly vegetable byproducts, into nutrient sources such as protein in a circular economy approach. And besides that, it can also be used for local production of protein sources, decreasing the value chain and also the dependency from other countries and regions. So today, people talk a lot about insect farming and protein, but insect farming is not just about protein. As mentioned before, there are a handful of opportunities that should not be overlooked, such as insect oil, that is very important fatty acid composition that can be used for different applications, and also the insect frass that has for several years been overlooked, but is a very important product for soil nutrition, and we are getting very important results on that. And for countries such as Portugal, Spain, or other South European countries, the organic composition of the insect frass can be a very important add-on for our soils compositions and nutrition of our plants. But there are other products as well, such as chitin and other bioactive compounds in insects that should also be taken care of, and we should also look for that as opportunities for developing new products for the markets. But when we are referring to insect protein, what can we find presently in the market when we are looking for this product? Well, we can find the different species that can be used to produce insect protein and insect products for feed. There are at least 7 species that can be used for that. But when we are going deep into the production styles and how people are raising insects, we can also see that different companies use different process from the substrate that they are using for rearing insects and the techniques that they are using for the production, what can affect the quality of the protein and even the profile of the fatty acids compositions. And we can also see that different companies are using different end products presentations, from whole insect meal to the fatted protein, and sometimes we are referring to with the same terminology to very different products. and that can be misleading in the market. So when we are talking about insect protein, we should start to try to standardize these products, because this is important to create trust in the market. And but as we are in the infancy, it is normal to see different players having different strategies and tackling the different challenges in different ways. So we believe in this time where we are getting from R&D based companies to increase their capabilities of production several times to go to the market, we have to standardize our products. Try to use the same terminology for similar products, ensure quality and good protein levels, and variations might not be acceptable. It's important to create partnerships with other companies and also with companies that are going to use our products to try to create a better understanding what is these products that we are creating, these insect-derived products that we are putting in the market. We should also try to have more homogeneity on our productions with similar colors, tastes, smells in the products that can affect animal acceptance. This is also very important to create a steady production and steady trust in different products that are appearing in the market. And feed safety is something that we always must have. These challenges to ensure that we have good products, that different companies are working in the similar goals, is going to be very important to tackle feed producers' fears, such as product homogeneity. Same producer sometimes presents different products. Feed formulations, when they are making their feed formulations, it's important for them to predict the quality of the products that they are buying and willing to use in their feeds. We need to increase the storage time of our products to get better trust in shipping and storage of insect-derived products. And we also need to ensure a steady supply of these products so that our clients can always have something to use in their new products, because feed producers are creating new products that are relying on insect-derived products. So it's important to always maintain the availability on the market so they can increase their use. So I believe with this background, where we find different products in the market with the similar terminology, where we still are developing the processes, increasing the quality of the final products, we surely need to create a market trust. We need to show to feed producers that is a strong market and with a great potential, and we need to create a strong value chain. So there are huge work not only in terms of R&D to increase production, to increase the quality, and to make the quality steady between not only producers, but even inside the same producer. But we need to create a value chain around the insect sector, so we can have upstream and downstream partners to put it rolling and creating a real market. I have seen in the comments before someone asking that we are maybe not going so fast from R&D to market, and we still need to validate some parts of the process. And this is also true, but we need to create a connection along the entire value chain to make people not only willing to use the products, but trusting in these products, so it will create a need in the market in the near future. That's why we created Insectera. Insectera is a Portuguese plan to create a new sector. It's a strong partnership around the process, creating new insect-based products for different markets. This project was submitted under the Next Generation EU. It was a call that was created by European Council and was created to mitigate the economic and social impact of COVID-19 crisis. Under this Next Generation EU, the Portuguese government created a plan for recuperation and resilience that is a mechanism to create new projects to change completely new sectors inside the Portuguese economy. Under these calls, there are the mobilizing agendas. The mobilizing agendas are huge projects that are being funded in Portugal to create new sectors or to change completely the sectors that already exist. Some of these projects include like creating hydrogen facilities from scratch with €1 billion investment, to others tackling the transports from trains to electric cars. But there are one that is completely dedicated to insects, that is Insect Lab. Under this project, we have 40 different companies and universities. We have 20 companies along the value chain from upstream to downstream. So we have farmers, we have industrial facilities for processing vegetables, we have feed producers, supermarkets, insect producers. We have the entire value chain. So we can create this, we can develop new products, we can test the new products, and we can create the products in the market and test them even with the consumers. In this project, we are willing to create strong partnerships that will ensure that the insect sector in Portugal will be a part of the future. It's also enrolling Portuguese entities, governmental entities, such as the Feed and Food Security Entity, and also some municipalities that will allow the installation of new economic areas fully dedicated to the production of insects. How have we organized this? Although feed is a focus for my company, Into Green, this project, this is led by us, created 4 different value chains. One value chain fully dedicated to food, one fully dedicated to feed, one to industry that includes ketosane and other applications, and one dedicated to bioremediation that includes the use of manure and other unlegal, as to say, byproducts. But in order to develop this value chain, we need to know better other things. That's why the R&D investment are still needed. We need to know better how to use the raw materials that are available, and we need to know better how to produce our insects with better efficiency. That's why we have 2 different work packages dedicated to that. That is raw materials and production work package, and the Insect 4.0 work package that is fully dedicated to automation and digitalization of the sector, creating full automated factories. After these 4 value chains, we have different products being produced for food, feed, industry, and also for bioremediation purpose, like a surface. But we have a common product that is grass. We strongly believe in grass, and we are creating a work package fully dedicated to increase the use of grass on our soil and to better process the grass to increase its value and the application. And we have one work package fully dedicated to One Health, to evaluate the environmental and social impact of this new sector. And finally, at the bottom, we have Insects to Market. That is a work package fully dedicated to commercial availability, marketing, and internationalization of these products. Focusing solely in the feed sector, we are willing to create a value chain. That's here where I believe that strong partnerships are going to be very important for the future of insect sector. What we are trying to do is to make different companies work with each other. Companies from upstream to downstream of the value chain. We are enrolling in this project farmers and the industrial producers of vegetables, from which we are going to get vegetable byproducts, but we are giving them back insect frass to increase crop production. We are going to train with them and try to improve technologies, not only to produce better insects, but to better process the vegetables, to give a better end to the vegetable byproducts that they already have. We are increasingly along the way to develop new products and process, trying to adapt and optimize our technologies, and always that we are creating new products, we are going to communicate the sector, the new products' advantages and impacts, and how it's affect the sustainability of the value chain. And at the end of the project, we will try to international to go abroad with our products and with this idea. So after several years of enrolling in the insect sector, we understood that in order to make it happen, we need to create a value chain as a complete enrollment of all the pieces around us, from upstream to downstream. That was the only way that we saw that we could get a better enrollment of the users of our technologies, as insects are just a link in a very long chain. This specific project will launch a new value-added productive sector that we believe it's going to be part of the future for the next few years, create four new factories, one dedicated to cricket production, one dedicated to Tenebra, Molitor, and one to BSF, and also a factory dedicated to chitosan production using pitting from these three species. It will also contribute to the creation of two R&D centers, one dedicated to bioremediation and one dedicated to One Health, and one logistical center to optimize the efficiency of these companies. All the four factories will be located in the same economic zone in Portugal, in central Portugal, and is a result of partnership of three insect producing companies that get together to create this environment that I believe will contribute to make this sector happen in our country. We hope to create 107 new products in processes and 160 new direct jobs. We will invest 25.6 million euros in research and development and about 50 million in a total project. We will create a new circular value chain and also contribute to create new companies, as we are going to establish an Insectpreneur Center where we will support entrepreneurs to get into this new industrial sector. Creating also the insect training network, as one of the main challenges that we are facing is the lack of specialized people to work in the insect sector. We want to put Portugal in the forefront of this sector, and we hope to create new partnerships internationally. So, what we expect to get from this project? We want to optimize our processes and to create new ones, and to develop this new insect reduction processes and methods. We want to create new products and create new insect fiber products, and to put the market as ready as possible for them. We are willing to contribute for the market developments and needs, so we can create a better environment for the sector development. So, in conclusion, we hope to contribute for a huge step forward in the insect sector through the creation of a new sector and the creation of links with partners, creating trust in the market. And we are also investing in public awareness, not only in terms of the quality of the products, but also as sustainability of this sector, as we believe sustainability is going to be key for the future of our insect sector. Many thanks.
Thank you,
Daniel, for a very nice presentation demonstrating how important it is to collaborate with different partners to bring a sector a step forward. And it's a very nice project in Insectera in Portugal. So thank you for that. And the floor is open for questions. Do we already have questions in the chat?
Not yet. Let's see.
So I take the opportunity to add, we are in the final stage of the project. I have presented the project for the first time in Porto. We were at the final stage already, but we are close to start the project. It's going to start on 1 of January next year. It will be a 3 years project, at the end of which it's a different project. It's not an R&D project, it's an investment project. At the final stage of the project, we have to present not papers, but factories. It's going to be a huge challenge, and I hope to have you here to see what we are trying to do here. It's going to be a very challenging next 3 years.
Lot of things to do.
Yeah.
Challenge, yeah.
Still no question in the chat.
Everyone is still typing.
Yeah, we have still time. So Daniel, can I ask you, can you tell us something more about the use of frass of insects in as I know that you are also working on this topic, so waiting for the question in the chat.
We have a team of researchers dedicated solely to frass in our team. We are working with vineyards, olive trees and pastures mainly, besides vegetables. And we got several interesting results. But besides what we believe is going to be a very important product, we never neglected the frass. But we were able to increase like potato production and tomato production. That was very nice. In terms of potato, in a commercial trial, we have done it more than once. We were able to steadily increase the production between 10 and 16% using this frass compared with mineral fertilizers. But what I believe is going to be the next step in terms of frass is if we can show that this frass not only increase the nutrition value of the soil, but also increase the health of the plant. That is something that we are trying to show, but we cannot do it by ourselves. We have partners to do that, but it will take still some time.
Thank you. So now some question from the chat. From Charlie, are you doing anything different than the other large company like Protix, InnovaFeed, and so on?
So sorry, could you repeat? I didn't.
No, well, are you doing anything different than the other large companies like Protix, InnovaFeed, and so on?
I really don't know if we are doing something really different. We are focused solely in byproducts. We are using products that we are not paying for them. They are not entering in the feed industry, but we are a completely vertical company. We are do from reproduction to processing. We do all the steps. We have also done our own engineering. It took several times. We started 11 years ago, and we created our engineering team, also inspired in other sectors, as Lars mentioned before, but trying to get the partners, to get the information from different partners, engineering partners, to develop our technologies. Several parts that, from what Lars said at the beginning, is also true. We validate them, like the possibility to use the heat from the insect production to use the energy for other sources, for other applications inside the farm. That is also something that we are using. So although companies sometimes don't talk much between themselves, they are going through the same path. So it's normal to get to similar conclusions and to apply similar process, maybe not exactly the same, but similar. So I really cannot compare exactly what we are doing differently. What I can say that we are doing differently from these very large companies, that we only raised enough for one factory till now, and we have relied a lot in public funding. We have several projects, not only in Portuguese level, but also internationally. H2020, EAAP grants, Prima, and also the Portuguese level, we have a lot. So, and we have
the transfer of knowledge is very important, I think.
Yes, and we have strong partnerships with not only companies. I have always to say that our growth depends a lot on the partnerships that we have with companies, not only universities, but with companies upstream and downstream from us, because they say to us exactly what they want, and we can develop exactly what they need, and that's important.
So there is one question: would you be able to share more insight into the chitin specific factory that you are planning?
Yes, I have not shown this slide today. I've shared it on Porto, but we are planning a industrial area where BASF production will produce it for several parts of other companies and activities, from BASF flies production to Tenerife molitor production and cricket. As everything is very together, very near, we can use the chitin that is being produced in these 3 units and give it to another place that is a chitin production unit. We are going to use a technology that has been developed by an R&D partner to transform the chitin into ketone. It's something that is still on not a very high TRL. We still need to invest several euros in the R&D part, but we hope in 2025 to be able to produce ketone from insect chitin. So we still need to invest some money in the R&D part.
Okay. There is another question about frass. Well, very quickly, what do you think about 70 degrees for 1 hour for frass?
Yeah, we are dealing with that. We are like 3 to 4 weeks to start our full-scale unit near where I am. I'm in the R&D unit. Our full-scale unit is 800 meters from here. We are going to put it running in 3 weeks' time. And we have all the machinery for 70 degrees in 1 hour for processing the frass. I really don't believe it's going to be needed to do so huge treatment, but we are going to deal with that. We have a internal project, not a funded one, to evaluate how this process is going to change the frass composition, nutrient availability, and also the macrobiological impact on that, and see if it is really needed and if it is affecting the value of the frass. Another question that is here is about the stabilization process. With this processing, we don't see the need for further stabilization, but we have tried to do a compostage after composting the frass after the production. We hope not to need that, because although it can stabilize the frass, maybe it's not the best approach.
Another question: how did you define the partners and leader in each work package?
Sorry?
How did you define the partners and leader in each work package?
How have I defined it?
Define. So how you select the...
Yeah. Well, this project, to be very frank and very transparent, this project was an opportunity. I had just 1 month to prepare the project. It was launched last August. I was during my holidays. So I looked for my usual partners, my 40 partners that I worked frequently in my company, and I called them during August last year to create the project. Fortunately, we just had to manage to merge the main lines that we were working, not being funded, and we merged that also with the strategic plans of the different insect companies that are enrolled in the project. And before the end of September, we went up with this project. We selected the leaders due to their main enrollments in these lines. So, for instance, we selected we have a R&D unit that is fully dedicated to engineering and to climate control and other kinds of stuff. They are going to manage the work package dedicated to Insect 4.0. That is the industrialization of the insect sector. So we decided, depending on what they are better on, we tried to put the 40 partners not in all the work package, but where they are really enrolled. For instance, we have the cricket farmers in the in-food, but not in the in-feed. They are also not present in the bioremediation work package, that is the use of manure. So crickets and Tenerife are not enrolled, but BASF is present in order, and we are trying to look, not our company directly, but other units and companies are trying to look for other insects that can be used there.
Okay, one more question. We have time or not?
One, yeah.
Yeah, very shortly. Are you willing to collaborate regarding the frass stabilization process, which I believe is a huge challenge?
Yes, it's true. It's something that we still have to work on. We can do it, as I mentioned before. We can stabilize it with our treatments, but we have to see how to better preserve the quality and the microbiology of the part of the frass, because we have very important microbiota in the frass that should be preserved.
Okay, thank you very much, Daniel. Thank you.
Thank you.
So the next presenter and the last one, not for importance. Hi, Sergey. So Dr. Sergey Smetana, he works as head of food data group at DIL since 2017. Sergey is an environmental impact scientist with a passion in life cycle assessment, and is dealing with the life cycle assessment is dealing with the question of complex food system analysis and define the role of novel products in our future. Sergey has a speak on taking account measuring sustainability of insect protein. Please, Sergey.
Thank you very much. I hope you hear me well. And then you should be able to see the standard questions. Okay. I guess you can see them, and it's a great pleasure for me to present some outcomes, some thoughts. And first of all, thank you, EAAP, thank you to you and Laura for the invitation to present this webinar. I wasn't able to listen to it all, but some parts which I heard and was able to join, that of course quite interesting as well. A couple of words about where I'm coming from. I'm coming from DIL, which is known as German Institute of Food Technologies. It's a registered-based association with quite a few locations, and as a registered-based associations, we are working a lot with different companies in the food and food technologies area, and of course we if we want it or not, we get tackled, of course, with the questions of insect and using insects for food and feed purposes. And more specifically, we are busy with the processing part of any food chain, but also processing of insects and insect biomass, but also with the questions of sustainability. And the project which I'm a little bit going to talk about is Chain, the project where we are quite active as a partner dealing with sustainability of sustainable insect chains. And the whole project is aimed to establish and define the strategies, define the possibilities for the development for further evolution of insect production chains in Europe first, and then the whole world. And of course, when we talk about sustainability, it's quite a big challenge, and there are quite a lot of interesting outcomes in the project. You are welcome to go and look at the website. And today I'm going to present just some bits and pieces which are connected with the sustainability and challenges we have there and how we're trying to solve them. We're doing that not only in the project, but as a deal with quite a few member companies who we have on board. Again, we are working on industrial scale a lot, and that shapes up the way we think and the way we think for the upscaling, and I think in the future for the sustainability of the production. Sorry, as main competences in our deal areas coming from biomass production all the way to the health being and well-being of humans, and tackling it from the three perspectives of assuring the safety ethnicity, and of course how you're going to deal with them, making sure that the food is, well, of course, tasty, that the food is safe, and it's pleasant to eat. And when you talk about the pleasure, it comes the structure and processing part, of course, connected with the safety and sustainability. And sustainability, that will be the part where me and my department are tackling about. I'm coming from a food data department, means that we work a lot with different types of data and different types of analysis of data. And of course, that's what we need a lot to assure that the sustainability is quantitatively and in a good shape assured. When we're talking about insects and insect production chains, and also in the project, and it always come to the point that it's actually quite complex when we talk about food chains, when we talk about insect production chains, insect value chains. It's not just the value chain itself, you know, when you have the chain of production, producing feed and insects, and finding what to do with that biomass, which is in the center part, but it actually targets a wider range of other possibilities and wider range of the food system, the whole food system, but also as questions connected to the legislation, questions connected to the consumer acceptance, questions connected to the impact on the environment, and of course, any potential rebound effects. And we're dealing with sustainability. We're trying to look at these different aspects and looking how we can include them the best of our abilities, but of course to the best of our capacities. One of the tools which we're using is called life cycle assessment, or we're relying on something that is called life cycle thinking when we're looking at any problem, when we're looking at any change from the perspective of the whole system. And the previous slide presented that system perspective, when we look at the whole chain and trying to grasp as far as possible all the incomes and all the outcomes in the systems. When I talk about incomes, that could be resources coming to the raw materials productions, you know, needed for any type of feed production. For example, we needed for the excavator which was used or harvester, which was used to collect the grains which were needed to produce insects, but also further any inputs in terms of labor, any inputs in terms of cost, economies, and so on and so forth, using holistic life cycle approach, which is ISO standardized. And there are also quite a lot of possibilities to use different types of professional software and, more important, databases, which are being out there, which have been established to a certain degree, and which has been proven that the quality of the data is quite high out there. But that's when we talk about more or less standard food chains. While we're talking about a novel protein sources, when we talk about insects, it's not that straightforward, and it's not that directly. We have to establish quite a lot of databases, and that was the first task in our work. And that is usually the first task in working with any type of novel products, with any types of novel protein sources. We actually have to tackle the lack of data availability. We have to establish some database, while for other more established production chains, it seems that there is a relatively small problem because they're already there and they don't see it as a problem. But in our cases, we actually needed to do that in order to make it work, in order to make all the models work and see what are the outcomes, what are the actually potentials for the development of insect value chains and sustainable potentials. We can, using this technique, using life cycle assessment, we're going to get results in different impact categories. We can also integrate results in single scores using different methodologies. What is more important, and also important for insect value chains, is that by constructing that databases and setting up the models and designing different life cycle assessment approaches, designing the ranges for the sustainability impacts, we are trying to prepare the insect value chains, insect productions to the consolidation to be in the line with product environmental footprint, those guidelines, so shortly PEF, which have been released by European Commissions for quite a lot of food categories and non-food categories as well. And of course, we're trying to align that, and even those product environmental footprints and product environmental footprint category rules are not established for the insect chains, but that we see in the future that might happen in a year or 2 or 3 or 5. Where these rules might be established not only for the insect chains, but also for other novel sources and alternative proteins upcoming on the market. Of course, in order to be ready for that, in order to set up certain standards, in order to say, okay, this is the golden value, this is the golden level which you need to achieve to be in the best representation for the sustainability. We need to know what are the ranges of environmental impacts. And I just write examples right now there, which we made for a few studies for the insect products. There are quite a few insect products available on the market, but also how working with the life cycle assessment of different products, we were able to identify different problems. For example, here's burger patties, which in the study was performed for 100 for burger patties out there on the market. And basically we went out in the supermarket and were able to buy a few burger patties and then cook them in the same way and they give it to the consumers, but also perform environmental impact of those categories and define, okay, what is the environmental impact. And you can see here, the higher it is, the higher the environmental impact, the lower it is, the lower. And insect burgers were quite in a good shape, were quite beneficial. Also, we performed study back in 2015, and if we took on a weight scale, that would look pretty much the same as on the left side. But when we were considering environmental impact as on the basis of the proteins, on the basis of digested proteins, we can see that insect-based products were quite in a good shape. Maybe not as good as a chicken, might be surprising. Maybe not as good as plant-based or soy meal-based proteins, but still in quite a good representation out there. It also was on one of the first studies out there, and of course you should tell right away that depends on the insect species, depends on how they were grown, depends on on the inclusion in the product. So that all actually matters, and that all what we actually got the first insights into okay, what are the challenges of performing a sustainability assessment of insect-based product as well. First of all, okay, what is the comparative basis would be. Second, okay, what are the function of insect products would be, and for the comparability issues, we need to know, okay, how is it specifically produced, and in order to talk about insect chains, we need to know all these varieties and somehow be able to compare them. Also performed previous studies on something called attribution life cycle assessment of insects, when we're just looking, okay, what are the hotspots, what are the impacts, and of course we can tell, the fresh insect produced, and if you eat them in a raw live way, they're the best from a sustainability point of view, because there is no processing included. The more processing you include is on the right side, there's milk concentrate, of course the impacts are higher. And of course, there's quite some variations depending on how the insect biomass, how the insect products are produced. If they're produced with the use of alternative protein sources, if they grown on side streams or used any other aspects. Also, some variations, biological variations within the species. All that actually matters for the environmental impact as well. When we talk about the consequential impacts, actually, here in this case, we can talk about this big chain of impacts, big production chains, which I was talking about. Then we can say, okay, with the increase of insect production and release those products on the market should potentially react. And we don't know up to now. Nobody clearly knows how the market reacts. Otherwise, everybody will be able to predict and play on the different shares and buy shares and get rich very quickly. But up now, we don't know how the market reacts because it's a complex system. But nevertheless, when we're doing different scenario building, we can assume that the market will be reactive in one way or another and develop these different scenarios. And we can see that depending on the insect substitution, which products have been substituted out there, and depending on what other aspects are touched on the market, the impacts could be quite high, but also could be quite beneficial in terms of influence on the environment. And that also gives us quite big ranges, quite a possibilities for the future use. So also in the beginning of the studies, we did literature review. So we looked at the different, plant-based, also insect-based, and other alternative protein sources like microalgae and more standard animal-based products. We were able to define the insect-based products actually laying in the lower range of alternative protein sources and getting quite close often to the plant-based, which is confirming also the outcomes we had in our previous studies as well. And that is quite true for most of impact categories. In some cases also insect-based products can be quite beneficial. For water footprint, I wouldn't put my hand on for it. Could be quite challenging also because of maybe not completely assuring water footprint methodologies applied in quite a lot of studies. So what we did in the Susan chain and what we're continuing to do, we are trying to define what are the environmental hotspots of insect production, where we are standing, and what is the future for that. And of course, it's quite easy. It's something called attributional life cycle assessment. And we are trying to define, okay, let's, in this example, having the three impact categories of greenhouse gas emissions, land use, and water footprint. And we can see that most of impact for the insect chains are coming actually from feed, as for almost all the insect species. And that's standard chain here when we have production of crops, and we use that and we can get quite a high impact. If we use any other substrates, it might be claimed that we use a byproduct or we use side streams, and that is completely true, only then the price is lower than the main product. If you use the same byproduct at the same price as a good quality feed, like protein concentrates used for chicken meal, that probably won't be completely true. So the price actually matters in this case. And we can say, okay, if we can get the same gains and can make it at the reduced price of 50%, then we can already talk about the reduction of 50% of the environmental impact. If we use waste, real waste, or we get something for free, that can be claimed that we are getting feeds at zero environmental impact. And that is something that the target area for insect chains. Of course, easier said than done, but necessary. That's something to look for, and that's something to search for in order to reduce up to 80% of environmental impact right there in the first step. Would be quite beneficial. Yeah, another point which we, of course, and all the insect producers are looking at the feed conversion rates, feed conversion efficiency, and of course we want to have it quite beneficial. They're different for different feeds, they're different for different species, and of course here taking some ranges which we're able to get from literature, which we're able to get from partners, which we're able to a little bit calculate. We don't have them all up to the final dot, but something that we are working always on is to fill those data gaps out there. And of course, another point which we're looking at the production of insects or farming of insects, and that of course comes usually when we have feed conversion, and most mass-produced insects in Europe are requiring specific climate conditions, and in order to keep those climate conditions, it comes at the expense of energy use. Heat, gas, ventilation, all that matters, and especially matters now. And of course, you don't want to keep insects, you don't want to grow them very long time. You want to have short development times, and of course, that also impacts the environment. Here, we try to connect with different feeds and somehow accumulate this knowledge, somehow bring in an integrated form. Of course, you can see them from being very short to being quite long, almost up to a year of development times for some cases. It depends, of course, on the feed quality, depends on different conditions as well. All that presented further results in the different environmental impacts. And here's on the right side presented environmental impacts 1 kilogram of dry matter insects, and you can see there some red parts, and those red parts we were able to establish because we collected all that information. We're able to put them in the models, we're able to run them, and now we are kind of getting the more or less complete picture of different insect species in this applying the project, also for the impact categories, and we can now actually work with those data and get some more additional benefits, because when you have all this massive amount of data, it's pretty hard to analyze and say, okay, make any types of conclusions. But nevertheless, one of the things which we can look at, and of course, it's the lowest impact of the best insect category, when the environmental impact in terms of greenhouse gas emissions are very beneficial, to the worst. And we have these two points. We also have these points for land use, for example, and then we can using different actually can get the same values by using the tool which is developed in Susan Chain project, and which is freely available to testing, also being adapted. It's not already alpha, beta, or maybe already gamma version, because it's being continuously adapted and will be more and more enhanced further for the better application, for the better use by the industry. It's quite simple. You can run out, you can get recommendations, of course, leave feedback. There is also feedback part, which is quite valuable for us. So once we got these ranges, we can then compare those ranges to the environmental impacts of the standard feeds or the standard protein sources, and tell, okay, where we stand, which scenario is actually more beneficial or less beneficial. But that's only part of the story. Next part of the story, we can look at the more integrated impacts. Okay, we can use different factors. We can use different factors which are, or different hotspots which are valuable for the insect production chains, and establish them in specific formulas, and then use those formulas as a part of multi-objective optimization, which we are using a lot. The point here is that sustainability is, as you saw, is a bit more complex than just environmental impact. And as I mentioned, we are trying to look not only at environmental impacts, and here in the black with the black abbreviations presented, those which were presented in the previous slide, those factors which are common for the insect production chains, and which I think are quite important for the environmental and for sustainability impacts in general. Of course, we can get also environmental impact category, social impacts, and trying to run them for different types of models, establish those objectives, establish those factors which can be used for something they call decision support system, which is basically represented with a tool, with a web-based tool, which will be available for the stakeholders, where you can look at the relatively simple web-based interface, input your data points, or design data points, or predicted points of your industry, of your company, and run analysis and define, okay, what will be the environmental impacts, what will be the economic impacts, and what you should be paid in order not to diminish any social potential breakdowns out there in the future. And what are we doing now? We're enhancing the background model which is out there. Okay, we have different models which are connected in different scenario modes, and then those scenario modes are integrated into the more beneficial. Let's say we select the 100, maybe 500 more beneficial chains out there, as mentioned, from environmental perspective, from social on. We'll include them in a superstructure database for Brightweight, for example, and we'll run with a multi-criteria analysis, so different types, and including that all together, we'll be able to define, let's say, that amount of 100 scenarios which are more beneficial, which should lead to rather optimal development of insect production chains, which then can be used as aim-in chains, and this web tool will be actually trying to bring to the closest optimal production chain by providing recommendations for the industry. And I guess it's time for me to come to the concluding points. First of all, insects is one type of alternative proteins, and of course, we still don't know quite a lot of information. We're still gathering. The point and the task of gathering all the data is a continuous task. But we already know that depending on the type of the feed, depending on the type of side streams, byproducts, continuous supply of side streams or wastes. I mean, the waste we don't like to use, but honestly, that will be from environmental perspective the most beneficial feed. But also the application of the insects for feed, food, energy purposes, other purposes. Of course, it's the work is going on with heating, with the frost, you know, where it can be established, what are the procedures out there. It's all needed, and of course we need to find the most beneficial applications, and that also impacts the sustainability in terms of environmental impact as well. It depends on the location, technology, society, resource use, all these aspects, you know, what kind is we at the point of the crisis, at the point of the availability of different resources, a possibility of apply alternative protein, alternative sources of energy, that all actually matters a lot. That all defines feasibility and sustainability. We need still research, tabletop research, we need experimental researches. We need all that, a lot of data. Without data, yes, we have model, we have opportunity to model those pieces of data which we are missing, which is quite powerful already, but it's still not the same as getting actually hands-on industrial quality data and putting them in the databases and the data banks which are able to cooperate and work with each other. But considering also other upcoming projects, will be quite possible, and that's what we can see in the future. And I would like to acknowledge Susan Chain project, but also all those projects which are connected to this topic one way or another. And of course, we are hopefully to work together with all the partners. And we are always happy to cooperate with any people working with the topic of insects or alternative proteins. So in this, thank you for your attention. And if you have questions.
Thank you very much, Sergey.
Thank you very much, Sergey. If you could, okay, so we can see the chat. So, any question for Sergey? No question. You know that I have no question for you, Sergey.
Laura, you have to struggle.
Okay, one question. Based on your findings, would it ever make sense for a sustainable perspective to use insect as feed?
Absolutely. We can go on. Well, I guess I have to explain. Yes, absolutely. The application of insects as feed matters. First of all, there could be different components of insects which can be used for feed. This is point number one. So even if they are not completely produced in the same sustainability level as standard feed, they're different additives. Well, additives like insect fats or the insect chitin, I heard, also could be potentially used in some cases for enhancing and improvement animal health. That is quite a beneficial area which we can see for the insect production. Of course, animal proteins and plant proteins for different animals could play a different role. So that also should be taken into account, you know, the digestibility and all these aspects and issues. So it should be clearly considered and carefully considered where insects can be used as feed purposes. Probably you cannot take and apply them in all the cases. In some cases, it doesn't really make benefits. In some cases, it does really improve the health and performance of animals which are being fed on different insects. That's point number one. Point number two, of course, if we can assure that we can produce insects on waste, and we can assure that it's safe and it's permitted legally, from environmental perspective, it would make completely sense.
Other questions?
Now, Laura, you have to think about the question. In case you still have any. Yeah. I know you don't have any because
well, you were very clear. That's why there are no questions, maybe.
No problem as well. But in any case, if people would have questions after all, thank you, Charlie. That, you know, the contacts are out there. You can always come back. I know there's some people still have questions for coming back to me with the emails. I'm not always that answering, but eventually I answer to all the people. So yeah.
No, you answer. You always answer to the emails.
Eventually. Yeah.
Turn.
Then, yeah, thank you, Sergey. I think we can give a wrap up of this afternoon's webinar. Thanks a lot, Sergey, for your presentation.
Thank you too.
Yeah, I really would like to thank all the speakers today. Really interesting presentations. I put down some keywords here, and from start to end, I noted here from R&D to commercial, the challenges, upscaling, matching the market needs, regulatory legal barriers in feed and foods, consumer acceptance, yeah, cooperation with different stakeholders, decentralizing. So you see when an industry is developing also new ideas how to optimize production will go into practice. Well, decentralizing is one of these topics, I think. More transparent partnering. Thomas focusing on the genetics. Genetics is also a very important discipline in insect production. The different modes of production. Different scales of production, small and large. The different products to sell, also attention for the functional properties of insect products, like chitin, antimicrobial peptides, the fatty acids. Standardization of end products, more homogeneous products, creating market trust. And yeah, studying for new processes, new products, new markets. And I think at the end, the presentation of Sergey is demonstrating that all these steps in the different stages of the insect chain affects the outcome of the sustainability assessment. So this, I think, is for today a very nice combination to see the developments in industry and also at the end the assessment on sustainability. And I don't know, Laura, if you have any additional items to conclude.
No, that's. I think that you really sum up all the different aspects that were touched today. I think that the presentation were also very well combined. You see, and with the last one, putting everything together and giving us the final output that is very important is the environment parameters. I have nothing else to say. I don't know if there is still someone that wants to say something in the chat. No, no one.
No, then thanks again to all the speakers, and thank you, Laura, also for sharing.
Then thank to the EAAP for
Thanks.
once again organizing this webinar. I think it's nice, it's important for the sector to have this kind of opportunity, you know, to have persons that are really working on the field to give us their expertise. And we had a quite nice number of participation, up to, I marked up to 95 people participating, so it was quite nice. So thank you very much to everybody. Please have a look at the EAAP website, at the Insect Commission website, for also information, and take into consideration also to participate to the next webinar of the EAAP. That will be also on a very hot topic. And well, you have our emails. You can write us if you have any question. Write to the speakers to have more information about their work and their presentation and to solve any question that you can have. Thank you very much to everybody.
Thank you.
Thank you.
Thank you. Ciao, ciao.
Bye.
Thanks, everyone. Ciao.
Ciao.